This video, we're going to look at a lot of terms that are tied to velocity. A lot of times you hear average velocity, instantaneous velocity, constant velocity. There's a lot of things that can be confusing. And so I just want to kind of get that down and separate those terms and make you really understand what they mean. First one is average velocity. And whenever you have average velocity, it's talking about the overall trip. You might be speeding up, slowing down, doing all this stuff, but somehow the over trip, if you take the entire displacement, or I think we use X in my equation sheets for displacement, you take the entire displacement and the entire time, and you put one over the other. It doesn't matter how fast or how slow you're going, but if you know how far you went total, and you know your time, then you can go ahead and calculate the average velocity. And once again, velocity is a vector, so direction would matter if you had it. So it's over the whole period. Whereas instantaneous velocity, yeah, you might be speeding up, slowing down, but at some point in time you might have been stopped. Like at the beginning, you might have started your car from rest. Your instantaneous velocity would have been 0. And then later on, you might be going faster than ever. You're trying to catch up and get somewhere. You might be going 75 miles per hour on the highway. That's talking about right there or right there. It's not talking about the whole trip. If I took the whole trip's displacement and took the whole time, and then look at one single location, then I could go ahead and I could solve for the overall average velocity. Now, if I wanted to solve for instantaneous velocity, which is any instant, so let me just pick a spot on this number. If I wanted to find the velocity at this instant, you could, and the best way to do it is to take two spots and find out. You're just pretty much going to do the same thing. The smaller the area, the closer you are to the actual instantaneous velocity, but you just take the displacement. Okay, what's the displacement in this small area? What is the time? How long did it take to get from here to there? So you take that displacement, you take that time, and you end up solving for velocity. That velocity, if you're just taking one small section, that's pretty close to your instantaneous velocity there. The smaller the section you do, the total displacement and the 2 times over. Once again, this might be the whole trip might have taken, 60 seconds. Well, this section right here took 0.06 seconds. If you use the displacement and the time it took for just that section, that's going to be close to instantaneous velocity, and the smaller this is, the more instantaneous it is. Okay, so let's look at average velocity versus instantaneous velocity. Average velocity, if you started at 10 and you kept on going faster and faster and faster at a constant acceleration, and you get to 30, it's really the same as saying if I went 20 the entire time, if I will cut it down the middle and 20 the entire time, I would have been exactly where I ended off. And so average velocity is just saying what would you have done instead? What was the average? Not how fast are you going now or how fast are you going later, but what is the overall average of the entire trip? What could you do instead? I could have went 20 meters per second and did exactly the same thing. Whereas instantaneous velocity, you in this graph right here, this person started at 10 meters per second. After 10 seconds, they were maybe going 15 meters per second. After 20 seconds, they were going about 20 meters per second. After 30 seconds, they were going about 25 meters per second. And at the end, they finally got to about 30 meters per second. Once again, at any one of those instants, they were going this velocity. Whereas average velocity, we're talking about the entire trip. Instead of this would be the average velocity, not the instant, not any single instant. Okay, average versus constant velocity. This is another thing. Okay, average velocity, it goes ahead and it takes, okay, this right here, this graph shows that this person was going 10 meters per second for 20 seconds. All of a sudden, out of the blue, instantaneously just sped up to 30. Didn't even show acceleration, just all of a sudden just became 30. And then he did that for 10, 20 more seconds. So your average velocity here was, you can go ahead and cut it down the middle. There's an equation that you're going to see next. But you can cut it right down the middle. The average velocity was right there. So this person was going 2 different speeds this entire trip. None of them were 20, but if you average those two together, because they have equal increments, 20 seconds and 20 seconds, so half this, half that, add them together, divide by 2, you get 20. That's your average velocity. Whereas constant velocity, this is when you were going the entire time. You never were faster. You never were slower. You were constantly going 20 meters per second. And if you keep on constantly going, you're going to keep on going 20 meters per second. And then here's your equation that you can use for either of these situations. Here I have two equal intervals. So it's pretty much taking an average of 2. If I take that equation right here and I type in 30 plus 10 divided by 2, I'm going to get 20 meters per second. That would be my average right down the middle. And then this one, another way to do it, if you have constant acceleration, so what's happening here is this person's speeding up, but he's speeding up at a constant rate. This also works the same way. So here, you go ahead and say, well, you cut it right down the middle. If you use this equation, you get exactly the same thing. And here you're saying, okay, I had initially 10, and then I got to 30, and I cut that down the middle. My average velocity would have been 20. So either situation, whether it's this right here where you're going two different speeds and but they're equal intervals, or you're constantly speeding up, this equation is going to work. Okay, now what happens when you have unequal intervals? This gets a little bit more difficult, but the best way to do this if you're given velocities is let's find what is the displacement during this section. What is the displacement during this section? And then we know, looking at this graph, the total time was 40 seconds. So here we know that, and we're going to use this equation, which this is just like an overall I made up equation. Just remember, v equals x over t, and if you rearrange that to solve for x equals v times t, so you see a bunch of v's and t's up there. So if I was trying to figure out the average velocity, I would go ahead and take this first segment and I would say, okay, the velocity was 10 and we did that for 10 seconds. So that's right here. Plus this section right here, the velocity was 30 and we did that for 10, 20, 30 seconds. So just by chance, I ended up having two numbers the same. And then, once again, extra parentheses, just in case you don't know what your calculator is doing, it's good to have. Then we look at the overall total time. Total time was 40 seconds. And so when you type that in, you got 10 times 10 plus 30 times 30. You divide that by 40, and you get 25 meters per second average velocity. Once again, it's not going to cut down the middle if they're increments. If the time, this was 30 seconds that you did this for, and this was 10, that's not equal. So it's not going to be a cut down the middle situation. You've got to do a little bit more. My process, find each of the displacements individually, and then take that over the total time, and that's what this equation I made up did. So here's an example. Bert was driving 30 miles per hour for the first hour, 50 miles per hour for the first hour, 30 for the second hour. What's the total average velocity? Well, it's hour and hour. So these can be 1 hour here, first hour, second hour. So this fit for one, this for one. And you can go ahead and you can say, okay, you do two ways. You can go ahead and say VF equals the VI plus VF over 2 equation, which is essentially the same thing as another equation we're going to look at, the same thing we did last time. So 50 plus 30 over 2, and you get 40. And it'd be 40 miles per hour. Use whatever unit you had going in. Or even to be safer, okay, if I'm going 50 miles an hour for the first hour plus 30 miles an hour for the second hour over a total time of 2 hours, like you saw in the last question or last example, this is always going to work. This ends up being that, and this ends up being 40 miles per hour. This is the safest way to go about it if you understand it. Okay, so going into this problem, 50 miles an hour for the first hour and 30 miles an hour for the next 2 hours. So we're going to go 2 hours at this. We're going 1 hour at this. So if we do this equation, we go ahead and say, okay, I'm going 50 miles per hour. Once again, each of these little things I'm about to do for 1 hour is v equals d over t. I always write it again. And so, sorry, x over t. v equals x over t, displacement nowadays, and the equation sheet is x. So I rearrange that, x equals v times t. So each of these right here represents the v times t to solve for the displacement. So that displacement plus this displacement, the next hour I'm going 30. I'm doing that for 2 more hours. I put too many parentheses, but it doesn't matter. You can't have too many parentheses. And then you went ahead and had to figure, okay, so 51 hour at that plus 2 hours at that, a total of 3 hours. And if you do that, you get 50 times 1 equals plus, open parentheses, 30 times 2. This is how I'm typing it into the calculator. Divided by 3, and you'll get, here it would have been 36.6 repeating, or 7 miles per hour. Once again, this is not to the right significant digits. If I was looking at this and try to do it to the significant digits, I see one significant digit there, I see one significant digit there. So this number, if I was actually trying to be significant, would have been 40 miles per hour. But once again, most students will do that, and that seems more accurate to me, even though this is ideally the right way to go about it. Okay, so just looking at the car's speedometer, what it would read. See how this is changing? The car's speeding up, the car's slowing down, and this changes. If it was average velocity, it would be saying the entire trip. And so here, it's telling you what it's doing at that moment. It's instantaneous velocity. Okay, and the defining constant velocity, that's when you stay one velocity and you don't change. You stay it the whole time. It's not average, because average velocity, if you go a constant velocity, your average velocity is your constant velocity. So it's velocity without acceleration, a equals 0. And if you're going 10, let's say 10 meters per second, 1 second earlier, and you're traveling at constant velocity, you will be going 10 meters per second a second later. You're not changing it.